Hello everyone. In the previous video, we have discussed about what is networking and what are the types of networks, network topology, and network devices, and then the OSA layers. And now in this section, we are going to learn about vehicle network architecture. So, what is vehicle network architecture? It is nothing but a structural framework that interconnects different electronic control units, which is also called as ECUs, sensors, actuators, and communication networks inside a vehicle. So, why we are using this means in modern vehicle contains a large number of electronic systems. For example, we have systems for engine control, braking, airbags, transmission, climate control, infotainment, and advanced driver assistance that is called as ADAS. So all these systems need to exchange information from one to another. So therefore, a communication network is required inside the vehicle. So what are the need for vehicular network means? At first, in modern vehicles, that contains a large number of sensors and electronic control units. Second, if every ECU communicates with each other, ECU using separate point-to-point wiring, the vehicle would require a large amount of wiring. So this wiring increases the cost, weight, and complexity of the vehicle. And next, it reduces in traditional all these wiring concepts were being used, but now in vehicle networks, this wiring harness has been reduced and allows multiple issues to communicate through a common communication network. So another important requirement is real-time communication in applications such as braking and engine control. Information has to be transferred quickly and reliably. So for that purpose, we have been using this. And vehicle network, it also supports distributed control. So different ECUs can perform different functions while communicating with one another. They also support diagnostics, reconfiguration, and future scalability. Then next, we will discuss about the what are the components presented in the vehicular network architecture. So the major contains first thing is ECU, that is electronic control unit. It is an embedded computer that processes information and controls actuators. So this is how it looks like. And the next one is nothing but a sensor. Sensor is mainly used to detect physical parameters such as speed, temperature, pressure, and position, and convert them into all these things will be converted into the electrical signals. And the third one is communication network. It mainly transfers messages between ECUs using some protocols such as LIN protocol, CAN, FlexRay, MOST, and Ethernet. So LIN is nothing but local interconnect network, CAN is a controller area network, and MOST is nothing but media oriented system transport. And the fourth component is nothing but the actuator. So it mainly performs a physical action based on commands that has been received from the electronic control unit. And finally, we are having the gateway ECU. So it is used to connect different networks inside the vehicle. It can perform message routing, protocol conversion, diagnostic and security related functions. So all these has been used in gateway ECUs, and this is how it looks like. So these are the diagrams of different components. And next comes the most important part, that is nothing but the major architecture, that is basic vehicular network architecture. So in this architecture, the first thing here given is driver. At the top, we are having the driver inputs. So the example of this includes the brake pedal, accelerator pedal, and steering input. When the driver performs an actions, so sensor detects the corresponding physical parameters. And the next one is sensors. So the basic example of sensors measure, that is nothing but it may measure vehicle speed, temperature, pressure, and position. And the next thing is the sensor information is then provided to the appropriate ECU, that is electronic control unit. So in this diagram, so here we can see different ECUs. So first thing is engine ECU, which manages the engine related functions. And the next thing is ABS ECU, that is nothing but, so it is an anti-braking system, so which is associated with the anti-lock braking system. And the next one is BCM, that is body control module. So it used to manages the various body related electronic functions. The next one is airbag ECU, which handles the airbag systems. And next thing is TCU ECU. So TCU is nothing but transmission control unit, which manages the transmission related operations. And finally, we have ADAS, that is nothing but advanced driver assistance systems, which supports the advanced driver assistance systems. So all these ECUs communicate through the vehicle network communication networks. So this diagram shows the several communication technologies protocols. This is called nothing but the protocols, which includes LIN, CAN, FlexRay, most, and Ethernet. So all these protocols support different functions. So different protocols can be selected depending on the requirements of the applications. So the communication network then connects to different systems. For example, the network can communicate with actuators, which performs physical actions such as controlling motors, injectors, valves, or relays. And the next thing, it also communicate with the dashboard or instrument cluster, where vehicle information is displayed to the driver. Another important system is the infotainment systems, which provides functions such as displays, audios, and for navigation purposes. So, and the next thing is, in this, we have also observed the gateway, which is shown here. So the gateway, which acts as an interface between the different communication networks. For example, a vehicle may contain a LIN network for which may be mainly used for low-speed body electronics. We will study this in this next video. So a CAN network for control applications, FlexRay for safety critical applications, and Ethernet for high bandwidth applications. So the gateway helps these different networks communicate with each other. Therefore, the basic architecture can be understood as, so this is the basic architecture which can be understood as driver inputs, sensors, ECUs, communication networks, actuators, and vehicle systems. So this is the major thing that has been presented in the basic vehicle network architecture. So in the next part of vehicle network architecture, we will see about the communication hierarchy, advantages, and then the applications of all these vehicle network architecture. Thank you.